and we'll start with examples. So last time we studied this part, maxima and minima. Okay, so our aim is to find a maxima and minima of a function u equal to f of xy. So in 12th, when y equal to f of x, this function is given. Say the function graph of the function is like this. Okay, then we have drawn the graph at the extreme points. Okay, this is the extreme point. So tangent is drawn to the curve at this point, and tangent is parallel to the x-axis. So this is another point A2, this is the point A3, this is the point A4, and this is the point A5. At A1, A2, A3, A4 tangents are drawn, and all the tangents, they are parallel to the x-axis. Slope of x-axis is 0. That is, slope at all these tangents is 0. That is, derivative is 0. So dy by dx equal to 0 will give stationary points or critical points. A1, A2, A3, A4, A5 are the critical points. Then second order derivative is obtained, and its value obtained at these points. If second order derivative is greater than 0, minima exists, less than 0, maxima exists, equal to 0, then we cannot decide. Okay, for that fourth order, sixth order derivatives are required. So this is for single variable. Y is function of single variable, that is for ordinary derivative. Now our aim is to study these properties for two variables, two independent variables. Okay. So first we'll define what maxima and minima is. Maxima, function f of x is said to have maxima at AB if f of xy is less than f of AB. So f of AB is the largest value. Okay. Minima, function is said to have minima at CD if f of xy is greater than f of CD. So f of CD is the smallest value. Critical point or stationary points, the points where first order derivative del f by del x equal to 0 and del f by del y equal to 0 are known as stationary points. What is saddle point? They are the stationary points where neither maxima exists nor minima exists. Okay, they are known as saddle point. Okay. Now two different methods are there. One is general method and another is Lagrange's method of undetermined multiplier. So we start with the general method. So aim is to find the extreme points. Extreme means maximum or minimum points of the function u equal to f of xy. So first step is to find first as well as second order derivative. So P, Q, R, S, T, right? Del f by del x, del f by del y, del square f divided by del x square, del square f divided by del x del y, and del square f divided by del y square respectively. Stationary points are obtained by solving first order derivative, equating first order derivative to 0. Okay. Then after finding the stationary points, find R, S, T at every stationary point. If at a particular stationary point r t minus s square is greater than 0 and r is less than 0, maximum exists. R t minus s square is greater than 0 and r is also greater than 0, minima exists. R t minus s square is less than 0, negative, neither maxima nor minima exist, and such points are known as saddle points. Whereas if r t minus s square is equal to 0, then it is not possible to decide whether maxima exist or minima exist. Okay. Long back, I think on 2nd April, we had this lecture. Now let me continue. Today is the 8th April, right now? So gap is there, but okay, no problem. We'll try to understand. So we'll go through with examples. So examples on the general method. You can write examples on general method. Right, first example. Discuss maxima and minima of f of x. Discuss means, again, it does not mean that you have to discuss and you have to leave it. Huh? You have to solve it. F of x comma y. Huh? X square plus y square plus 6x plus 12. So right, given, start writing with me, given f of xy equal to, I am audible, no? I am audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. F of xy equal to Okay, thank you. X square plus y square plus 6x plus 12. Okay. Then on differentiating partially with respect to x and y.
Sir, the page.
Oh, sorry. अरे यार, भूल गए थे, नीरज का. Right, f of xy equal to x square plus y square plus 6x plus 12. Done. Differentiating with respect to x and y. Del f by del x. Derivative with respect to x. 2x. Derivative of y square is 0. Derivative of 6x is 6. Del f by del y. 2y. That's it. So this is p. This is q. pq. Okay. Next one. R. Del square f divided by del x square. So derivative with respect to x. What is that? 2 s del square f divided by del y del x. So derivative of this with respect to y, huh? Already we obtained del f by del x. We want to find derivative with respect to y now. So what is derivative of 2x plus 6 with respect to y? 0. And del square f divided by del y square. So derivative of this with respect to y, 2, which is p. Hope everyone is getting this. First and second order derivatives. Okay. Now stationary points. Are obtained from del f by del x equal to 0 and del f by del y equal to 0. So what is del f by del x? 2x plus 6 equal to 0 and 2y equal to 0. So from here x is minus 3 and y is 0. So here fortunately we have only one value of x and only one value of y. Okay. So stationary point is minus 3, 0. Write value of x first and then value of y. Then write next. Now r equal to, r is already known to us 2, s is 2, p is 2. Okay, they are not constant, usually they are the functions of x, y. Then we have to substitute x equal to minus 3 and y equal to 0. And then we have to find r st at the point E. But here it is not required. Now write down r t minus s square. R t minus s square. 4 greater than 0. And what about r 2 less than 0? So r t minus s square greater than 0 and r less than 0. So what exists? Minima or maxima? Yes.
Maxima. Maxima.
Maxima exists at a minus 3 0 and maximum value is at minus 3 0. Y0x is minus 3. So 9 0 3. Understood the example? Maxima exists at minus 3 0 and maximum value is f max equal to 3. That's it. This is the solution. Next example. Can I change the page?
Yes, sir.
Let me change the page now. Find extreme values of the function three x square minus y square plus x cube. Here f of xy equal to x cube plus 3x square minus y square. Okay. Now differentiating partially with respect to x and y. Del f by del x. 3x square plus 6x r del square f divided by del x square. So derivative of this term with respect to x again. S del square f divided by del y del x. So derivative with respect to x is already known to us, 3x square plus 6x. Derivative with respect to y now, 0. Derivative of this with respect to y. So now p, q, r, s, t is stationary point. Stationary points are obtained from del f by del x equal to 0. You have to take all possible combinations. 0, 0 and minus 2, 0. Okay, x 0, y 0, x minus 2, y 0. Take the first stationary point. 0, 0. Find R S and T. R contain x, therefore substitute the value of x. So R is 6, S is 0, T is minus 2. RT minus S square less than 0. What happens? Yes. Neither maxima nor minima exist. Known as saddle point. Neither maxima nor minima exist at 0, 0 and therefore it is known as saddle point. Okay. Let me change the next page. Can I change the page now? Next, right? Now write down at B we'll see what will happen at minus 2, 0. So R minus 6, S is 0 and T is minus 2, fixed value. Okay, and what about the R? So RT minus S square is greater than 0 and R is less than 0. Therefore, maxima exists. Maximum value is y equal to 0. F max equal to 4. Hope you are getting what we are doing exactly. Next. समझ में आ रहा है सबको? Are you getting the concept?
Yes, sir.
Yes, sir. Yes, sir.
चलिए ठीक है, चलिए और कुछ एग्जांपल सॉल्व करते हैं. Find extreme values of the function little bit difficult example. Plus 72x. If given okay, done. Differentiating partially with respect to x and y. Three x square plus 3y square minus cube. R. So derivative of this term with respect to x. Derivative of this term with respect to y. T. Derivative of this term with respect to y. So we have obtained all the derivatives R, S, P. Now our aim is to find the stationary points. Can I change the page? Have you written the derivatives?
सर
हाँ
सर वो एस कैसे ऑप्टेन किया एक बार बताओ ना.
कौन सा पार्ट?
एस एस
एस क्या कर सकते हैं ना, दो टाइप से फाइंड कर सकते हैं. यहाँ पे हमने हियर वी ऑलरेडी डिफरेंशिएटेड दिस विद रिस्पेक्ट टू एस एक्स. सो इसको डिफरेंशिएट विद रिस्पेक्ट टू वाई करो तो 3x स्क्वायर का डेरिवेटिव 0 आएगा. x कांस्टेंट है ना, डेरिवेटिव विद रिस्पेक्ट टू y. y स्क्वायर का डेरिवेटिव 2y आएगा, 2 into 3 so 6y. ओके 30x 0 आएगा, 70 0 आएगा. हाँ, एक हाँ नहीं तो क्या कर सकते हैं, ये जो डेल एफ बाय डेल वाई है ना, ये इसको विद रिस्पेक्ट टू x कर सकते हैं. ऑलरेडी भी डिफरेंशिएटेड विद रिस्पेक्ट टू y ना, हमें xy चाहिए. So now you differentiate this with respect to x. So derivative of 6xy 6y, derivative of 30y derivative with respect to x है तो 0 आएगा, दोनों सेम ही आएगा.
ओके सर.
ठीक है, चलो नेक्स्ट.
सर वो टी का थोड़ा पार्ट दिख रहा नहीं है.
6x minus 30
नहीं 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 वो
dy
डेल
square है।
del
डेल
square
स्क्वायर
f divided by del y square.
डेल वाई स्क्वायर
Okay. Next. Sure. Now on stationary point.
Sir, page
और कुछ नहीं. Stationary points. Stationary points are obtained from del f by del x equal to 0, del f by del y equal to 0. That is 3x square 3y square minus 30x plus 72 equal to 0 and 6xy minus 30y equal to 0. What we can take common? We can cancel 3. So x square plus y square minus 10x plus 3 is cancelled. And what we can take common from here? 6y. Okay, so we can solve the second equation. Y equal to 0 and x equal to 5. But that is not the point. 5, 0 is not the stationary points. Understood what I am saying? 5, 0 that we are getting from the second equation is not a stationary point. Stationary point is one which satisfies both the equation. Okay. So now in the first equation, I'll substitute y equal to 0 and we'll see what will happen. When y equal to 0, see how this will change. Substitute y equal to 0. X square minus 10x plus 24 equal to 0. That is what is stationary point? X equal to 4, y equal to 0. X equal to 6, y equal to 0. So when y equal to 0, the values of x are 4 and 6. So from here we'll get the two stationary point. Okay, this is first part. Now it may be possible that x may be 5. So when x equal to 5. Now understand how this equation will change. Substitute x equal to 5, 25 plus y square minus 50 plus 24 equal to 0. So add, subtract, you get y square minus 1. So y square equal to 1, y equal to plus minus 1. So stationary points are x is 5, y is minus 1. Should be C. And D, x is 5, y is 1. 4 stationary points are there. Hope you might have understood. Understood the procedure? Is there any difficulty while understanding this page? Any doubt? Let me know. If any doubt is there, let me know.
sir,
Uh-huh.
Sir, why put that y equals 0 and x equals to 5 in equation this? We can't take
Uh,
other values.
okay, just 1 minute. See, you might have understood that what is stationary point? The points which satisfy both the equation. Which both equation? Del f by del x equal to 0 as well as del f by del y equal to 0. Na? Correct? Na?
Yes.
That is, suppose I want to solve this equation. Ax plus y equal to 5 and ax minus y equal to 3. And from here, say I take x equal to say 3 and y equal to 0. But that solves this equation only, na? Does it solve this equation also? X equal to 3 and y equal to 0. Does it mean that x plus y equal to 5? No. So this is answer for this equation only, not for this equation. So whenever I want to solve both the equations simultaneously, what I have to do, I have to solve these two equations simultaneously. Huh? Just I have to subtract or add and then I have to get the answer. That thing cannot be done here since degrees are different. So here the procedure is solve one of the equation which is simple. So in this case equation number 2 was simple. Y equal to 0 and x equal to 5 is obtained. This is not the stationary point. 5, 0 is not the stationary point. How will you understand that? If you substitute 5, 0 here, na, here, so will not get equal to 0. Equal to 0 yet nahi hai. Therefore 5, 0 is not a stationary point. Therefore we substituted y equal to 0 in first equation. From there the values of x are obtained 4, 6. From there we got the stationary point. Again we substituted x equal to 5 and then we got 2 more stationary points. Clear? Aim is to solve both the equations simultaneously. Therefore, simultaneously means we want to find points which will satisfy both the equation, not a single equation. Concept clear? Or till any doubt is there?
Clear.
Okay. Now what we'll do, we'll start with the first stationary point and we'll see what is RST. Okay. So write down at a stationary point A40. So right. Right with me. Write R from the first page. So R and T, they are same. At what is the first stationary point? 40. R equal to What about T? R and T both are same. Okay, so R T minus S square greater than 0. Okay, so this conclusion. Maxima exists at A40. F max equal to, take the equation. (15 into 16), how much is this? Use calcium, find this. (72 into 4).
$112.
Absolutely. Okay. Next. At what is the second stationary point? At 60. R and T both are same. Both are greater than 0. RT minus S square is greater than 0. R is greater than 0. Therefore, B it should be. Minima exist at B60. F minimum. Who obtained this answer?
108.
Okay, let me change the page. Hope you are getting
Sir,
it.
1 minute. 1 minute.
Write it, no problem. Next, change the page. Five minus one. Can you solve the remaining part yourself? I think these two are saddle points. One base is 6y.
6
Yes. Make a small table. Condition, conclusion, remark. What are the stationary points? A40, B60, C5 minus 1, D5 1. RT minus S square is greater than 0. R is also greater than 0. Minima exist. Neither maxima nor minima exist, and therefore the point is known as saddle point. This should be the final result. Are you getting it? Understood the whole procedure, what we are doing? Next run. Let me change the page. Any doubt in this? Okay. Any doubt in this example? Any doubt in this example? Okay. So right. Next. Show that minimum value of okay. Next run. Find extreme values of the function last point. Lagrange's method of undetermined multipliers. Right. This method is used. This method is used to find stationary points of a function having 3 or more independent variables. Drawback is that we cannot decide whether maxima or minima exist. We cannot decide whether maxima exists or minima exists. Just then what we can do with this method, we can find the stationary points. Okay, run procedure. to optimize optimize means to minimize or to maximize. In fact, our aim is to optimize everything, right now what your aim is, to do the minimum study and get the maximum marks. That is the optimization that you want during the engineering, right now, or do minimum work and get the highest package after doing the BE. That is our aim, that is our optimization aim, right now. So what my effort is, teach minimum things and students should get maximum marks. That is what I'm expecting, right now. So everyone in life is want to optimize whatever his aim is. Okay, so to optimize, u equal to f of x, y, z. This is the function under the condition, but some conditions are there. Under the condition phi of x, y, z equal to 0. So the function which is to be maximized or minimized is written in this form, u equal to f of x, y, z. And the condition is written as phi of x, y, z equal to 0 is written. So construct a function capital F equal to u plus lambda phi. F equal to u plus lambda phi. Lambda is known as Lagrange's undetermined multiplier.
हेलो सर.
हॅलो
सर
सर,
फिजिक्सचं
लेक्चर आहे
लेक्चर
सर
आहे
आता
आता.
फिजिक्स.
मेसेज
हो ना,
आलाय मॅमचा.
10:40 ला आहे ना. अरे हो रे राजा, 10:40 ला आहे ना. नाही,
हो
10:30
सर.
ला असते की नाही. बरं ठीक आहे,
हो
एवढं
ना.
हा
संपवतो.
सर 10:30
हो,
टाइम
ठीक
झाला
आहे
सर.
एवढं. अरे हो राजा, 2 लाईन लिहायचे आहे, ते परत मला सर्व रिपीट करावं लागतं.
सांगा सर, सांगा.
हा, अरे वेर लॅम्बडा इज, सांगून दे मला. लॅम्बडा इज लॅग्रांजेस अनडिटरमाइंड मल्टिप्लायर. Lambda is Lagrange's undetermined multiplier. Okay, then differentiating with respect to x, y, z and equating to 0. Differentiating with respect to x, y, z and equating to 0.
Undetermined.
Lambda is Lagrange's undetermined multiplier. Right. Then solve above equation simultaneously and find lambda x, y, z. That's it. You can leave.
सर प्रेझेंटी.
सोडले मी.
सर अटेंडन्स.
हेडफोन काढले त्यांनी.
इयरफोन काढले सरांनी.
सर लास्ट लाईट काय आहे?
लास्ट लाईन काय होती?
Solve above equation simultaneously and find del x by z, lambda x by z.
कौतुक परत सांग.
Solve above equation simultaneously and find lambda x by z.
लॅम्बडा एक्स बाय झेड.
हो.